All right, so for example 2.28, we are interested in resolving vectors into components, yes. All right, so let's express V, which we have components 8, -3, -3, as a sum of orthogonal vector such that one vector has the same direction as our vector U that we're given. What on earth? Goodness gracious. Sorry about that, guys. Right, so our vector U is equal to 2, 3, 2. All right, so we're going to follow the same steps that we had up above. The first thing that we're going to do is calculate the projection of V onto U. Okay, well, we know that the projection of V onto U, we'll call that our vector P, is equal to the dot product U dot V divided by the magnitude of U squared times our vector U. So we are interested in the dot product of U and V divided by the magnitude of U squared. And we want this to be in the direction of U. All right, so we'll go ahead and calculate the numerator and the denominator. So 2 times 8 is going to give us 16. 3 times -3 is going to give us -9. 2 times -3 is going to give us -6 over our magnitude squared is 4 plus 9 plus 4. And once again, we want to make sure that we're focusing on our direction U. So this is giving us 1 over 17 into 2, 3, 2. Or the vector is 2 over 17, 3 over 17, 2 over 17. Okay, so step 2, because this is just the first component, is to find the second component. Compute Q, which is the difference between our vector V and the projection. All right, well, our vector V was 8, -3, -3. And the vector that we just computed was 2 over 17, 3 over 17, 2 over 17. All right, so when we do the subtraction, we're going to get some not very nice numbers, but that's fine, right? So 16 over 17. I'm sorry, we're subtracting, we're not multiplying here. 8 minus 2 over 17 is going to give us is 136, so minus 2 is going to give us 134 over 17. -3 minus 3 over 17 is -51 minus 3 is -54 over 17. And then once again here, we're going to get now the -51 minus 2. So -53 over 17. All right, so go ahead and check our answer. Okay, so we've calculated our projection and got 2/17, 3/17, and 2/17. So this is our first component. And then we've calculated their difference, yet our second component. And then, of course, we can actually check our work by taking the dot product and proving the two vectors are orthogonal. Yeah, so I should have done that. All right, so the dot product of P and Q is the dot product of 2/17, 3/17, 2/17, with 134/17, -54/17, -53/17. So notice that we've got that 1/17 for everything. 2 times 134 plus 3 times -54 plus 2 times -53. So, sure enough, that's going to give us 0. Okay. And does this actually, it said to express it, right? Yeah. So it said to express the sum. So we're literally just going to write v equals p plus q. So our vector v was 8, -3, -3. And this is equal to p, 2/17, 3/17, 2/17. Plus q, so 134/17, right, comma. What did I do here, guys? No mistake. -54/17, comma, -53/17. Goodness gracious notation, right? All right, nicely done. Well, let's take a look actually at this checkpoint now. So for the checkpoint, we want to take the same process, except now we're given the standard unit vectors for our components. So let's express v equals 5i minus j as the sum of orthogonal vectors such that one of the vectors has the same direction as our vector u, which is 4i plus 2j. Go ahead and pause here and give that one a shot on your own.